Good afternoon. My name is Bethany Maddox, and I'm a member of the customer care team here at Vitech Corporation. I'm very pleased to be your host for this webinar today as we discuss the power of iterative interviews in modeling existing systems. Before we get started, I'd like to take a moment to review a few technical details. First, questions. Please feel free to submit your questions at any time via the Q&A function in the GoToWebinar window. We will be monitoring these throughout today's event, and we do plan to respond to questions at the end of the webinar, so please send them in. The webinar is being recorded today, so if you have technical difficulties during the presentation, we will have an online archive with this presentation available within 24 hours. I believe that takes care of our housekeeping matters, so let's get started. I'd like to take a moment to introduce Zane Scott, our speaker for today's presentation. Zane is the Vice President of Professional Services and Training Organization. For the past 30 years, Zane has built a skill set which enables him to provide insight and guidance to individuals and companies as they improve organizational processes and methodologies across their organizations. Zane is the author of numerous white papers, including 9 Laws of Effective Systems Engineering, and is also the co-author of Vitech's Primer for Model-Based Systems Engineering. Please join me in welcoming our speaker for today, Zane Scott.
Thanks, Bethany and Eva and Lindsay in the booth. Good afternoon, and thanks to you for joining us in our webinar on the power of iterative interviews. We really appreciate your taking time from your busy day to spend the next few minutes with us as we discuss this technique for modeling existing process systems. The technique we'll talk about today is one we developed out of the need to be able to model existing process systems rapidly and responsibly. It was developed over a period of time by a team consisting of Victor Dingus and Nick Grabar of Transformation Networks, Inc., working with Zane Scott and Joe Malley of Vitech Corporation. We use this technique to model a set of existing processes for the purpose of improving those processes and identifying points at which they could be automated. In order to do that, we first had to develop models of the existing processes, then identify automations and improvements to them, and finally revise the models to reflect the desired end state. The process that I will describe for you today was developed in response to the limitations of the traditional approaches to modeling existing process systems. We will begin by briefly discussing the traditional techniques and then talk about our response to the problems they presented. I will then describe the new iterative interview technique in some detail, together with the rationale for our approach. And finally, we will consider the results we were able to achieve with that technique and conclude with a discussion of some unanticipated benefits that arose from our use of the iterative interviews. As I said, the problem that we were addressing involved modeling existing business processes. We needed to get a clear picture of the processes as they were instantiated and actually used. In the world of classical systems engineering, we typically confront 3 types of problems. The first is the most familiar, that of the top-down design of an unprecedented system. This is not, however, the type of problem that we are addressing in this discussion. Although the top-down design problem has been the prevalent setting for systems engineering in the past, today's world more often confronts us with problems born in one of the 2 additional areas: Middleout Design or reverse engineering. Reverse engineering is used to deal with the replacement of legacy systems. In the project in which we developed the iterative interviews approach, we were engaged in a process improvement effort. This falls into the area of Middleout Design problems, in which the design team must model a process which will essentially remain in place, and then design in the changes and improvements which are necessary to meet the changing needs of the process environment. This requires an accurate picture of the existing processes as a basis for moving forward with improvements. In taking on this particular challenge, we were confronted with the limitations of the two traditional approaches to modeling existing processes. The first of those approaches bases the model of the as-is processes on the design documentation under which those processes were originally created. The problem with that approach for us was that it results in a model of the process as designed, rather than a picture of the process as implemented. We needed to base our as-is picture of the processes on the processes as they actually existed in practice in order to establish a trajectory for the improvements. Without an accurate picture of the as-is state of the processes, it would have been virtually impossible for us to establish a trajectory from their existing practice to their improved state. Therefore, we couldn't rely on the process design documentation to produce an accurate picture of the existing processes. The other traditional approach open to us grows out of the old days of time and motion studies. In this approach, the process modeler observes the processes in action and takes measurements of time and motion to recreate the process in the model. The problem here is that the act of observing the process will almost always in some way alter it. Werner Heisenberg, who is better known for his uncertainty principle, made this observation with respect to physics. He concluded that observing a physical process will inevitably alter it. I have personal experience with how this works in industry. I spent a college summer working in a velveteen plant. Because of its unique nap, velveteen must run through the machinery in one direction only. When the cloth exited a machine, it was layered down onto wooden pallets. But the front end of the cloth had come out first and was therefore on the bottom of the stack. One of the jobs I did that summer involved flopping loads of cloth so that the right end of the load would enter the next machine first. This meant that each 1,600-yard load of cloth had to be picked up and flopped onto an empty pallet so that the end of the cloth which had come out of the previous machine first and was at the bottom of the first pallet would again be on top so that it could enter the next machine first. That was hot and heavy work. We were paid on a piece rate based on how many yards of cloth we could flop in a shift. A number of our co-workers at the plant delighted in making the lives of the college summer help miserable. They worked hard at getting us into trouble with the management and making it look like anything that happened to impede production was our fault. During the course of the summer, we found out that the piece rate standards on which our pay was based were set using a percentage of the single shift production record by a crew of floppers. That meant our production process and records were being scrutinized. Tired of being tortured by our coworkers, we decided that the way to get back at them was to break the production records. Then the time and motion studies would reflect a higher record, and that would thereby raise the piece rate standards, making it necessary for our antagonists to work harder to reach their piece rate bonuses. We managed to pull this off 3 times in one summer. The first time we broke the record, we did it by working all out throughout the entire day. The second time we broke the record, we did it by working straight through our morning and afternoon breaks. The third time we broke the record, we did it by spelling each other so that we could skip the breaks and eat our lunches standing up as we worked. Each time we pushed the production records further and further out. Because we knew that our production was being scrutinized and that we could use that scrutiny to get even with our coworkers, we altered the process. Although process alterations are not often that dramatic or nefarious, when processes are observed, the day-to-day practice is almost always cleaned up or altered in some way. Like the distortion in the production records of the corduroy plant, these distortions, however small, reduce the accuracy of the picture of the as-is processes. That's the problem with using side saddle observations to get an accurate picture of the processes. Because of these limitations, we looked around for a new, more accurate way to come up with a model of the processes in their as-is state. Rather than observe the processes, we decided to conduct interviews about the processes. That way, we could get sufficient details at a high level of accuracy and construct our model from the data elicited in the interviews. The first question, of course, was who to interview. In order to get the most accurate picture of the processes, we needed to be sure that we interviewed people who were knowledgeable about the processes as they were implemented. We decided that this accuracy was best promoted by conducting our interviews in close proximity to the practice of the processes. We needed to talk to people who were intimately familiar with the day-to-day implementation of their processes. Ideally, this meant interviewing the process owners. These were the people who were directly responsible for the implementation of the process. They had the best understanding of the problem, solutions, and workarounds involved in implementing the processes in the real-world environment of their daily business. So we set out to find, gain the confidence of, and establish a dialogue with the process owners. This wasn't always easy to do, but we found that the iterative interview process itself generally won over the process owners in short order. So now let's take a look at the iterative interview process itself. We based our approach on a concept out of Lean Six Sigma. This concept views the process as a flow from a supplier who provides inputs to a process which produces outputs for a customer. Known by its acronym SIPOC, S-I-P-O-C, this concept provides the basis on which we develop the iterative interviews. We began by designing interview questions targeted to elicit the information about each item in our process framework. Over time, we determined that it made the most sense to ask the questions out of the order in which they appear in the acronym. We generally started the interview process at a very high level, explaining to the process owners that the questions were directed to the entire process. At the initial stages, we did not strive to elicit a lot of detail. We generally begin the interview itself by asking, what is it that you make or produce? This might be a tangible product or a service. At a high level, the answer might be something like furniture or financial reports. The answer here specified the output of the process. This is the O in SIPOC. We followed up on this question by asking, who uses what you make? The answer to this question identified the customers of the process. This is the C in SIPOC. Once we established the identity of the customers, we asked, what do you need to make your product? Their answer identified the inputs necessary for the process, which of course are the I in our acronym. The next question, obviously, is where do you get your inputs? Here the process owners identified the suppliers who formed the S in SIPOC. With the context set, the final and most important question was, what do you do to the inputs to make the outputs? This answer described their processes and established the base for our process model. Modeling the process then proceeded by breaking the process down into steps and using the same interview questions to drill into each step. For each process step, we would establish the outputs, customers, inputs, suppliers, and a more detailed description of the process itself. As we fleshed out the model, we were able to link the process steps together with individual process steps becoming the customers of previous steps and the suppliers for subsequent steps. This chain became more and more detailed, establishing a better and better picture of the overall process. As the granularity of the process description grew, so did the complexity of the model. Any given process step might have several different inputs, and any input might come from multiple suppliers. The same is true of multiple outputs and multiple customers. As we webbed these process steps together, a more and more granular and more complex model of the existing process was developed. Once we advanced the interview process to the desired level of granularity, we synthesized our notes and information into a computer-based model of the process. Using Vitex Core as the computer modeling tool, we generated a graphic representation of the model for process owners. We then took our process pictures back to the owners for their consideration. Although I've used a generic flowchart for illustrative purposes here, we found that a structured diagram, like the functional flow block diagram or enhanced functional flow block diagram, was easily understood by any process owner. The owners would then critique the representation for accuracy. Often they identified places in the representation where we or they had not been clear in our understanding of the process. In addition, they almost always began to identify from the representation ways in which the process could be made more efficient. We recorded their comments and marked up the representations accordingly. We then incorporated the modifications and changes back into the model, produced new representations, presented the representations back to the process owners, and received their additional comments. We iterated this process until the process owners were satisfied that the representation was entirely accurate. At that point, we could be reasonably certain that we had an accurate model of their as-is process. To review, our iterative interview process involved interviewing the process owners, assimilating their information into a model of their process, presenting a representation of the process model to the process owners, iterating those steps until the process owners were satisfied that our representation was an accurate depiction of their processes, and then getting their agreement to it. Now, what did this approach offer us that we could not find in the traditional approaches? The first thing that we gained through the iterative interviews was clarity. Our picture of the process was not distorted by misunderstandings of our modeling efforts or misrepresentations or changes to the process as we observed it. We were able to see clearly into the process as implemented. In addition, our model was accurate. It was a model of the processes as accurately implemented on the ground by the process owners. It was not the idealized picture of the process contained in the design documentation, but the actual process as carried into practice in day-to-day business. Our model, therefore, provided a solid and accurate base from which to design and implement process improvements. The obvious results of this iterative interview and modeling process is a model of the process from which we can derive the existing requirements and determine the improvements that are to be made using requirements that are supplied to us by the stakeholders, driving the process improvement. From the model, we can derive the requirements that drive the existing processes. These form the starting point from which we can add the additional requirements presented by the charter of our improvement efforts. By using the combination of the existing and new requirements, we are able to plot a path from the system as is to the to-be state that we desire. With the accurate representation of the existing processes, we can then generate alterations to the model which result in virtual prototypes. Instead of having to pilot various improvements to the process, causing actual changes in the business enterprise in order to test the efficacy of our improvements, we can use the model to simulate the impact of various alternatives on the process. This enables us to generate virtual prototypes with which to test proposed changes at very little cost in terms of effort and disruption. Another very important consequence of the iterative interview approach is that process owners build up a sense of ownership in the model created. Because the model came from them and accurately reflects the process as they know it, they have a vested interest in the model. This generated an unanticipated but very important benefit of the iterative interview approach. The challenge of nurturing change in any process is a formidable one. The iterative interview approach to constructing an as-is model of the process fostered a very beneficial solution to the problem of implementing change in any system. In every stable system, even one with problems embedded in it, the inertia of the status quo erects a wall against change. We half-jokingly say that the 7 most powerful words in the English language are, "We've never done it that way before." Nevertheless, this wall is a formidable and solid one. It acts effectively to prevent almost any change thrown up against it. The most effective way through this wall is through buy-in. If the process owners and the implementers buy into a proposed set of changes, it creates a way through the initial wall of the status quo. This is critical to any change effort. How to build this buy-in is the subject of much research and reporting. The most effective way that we can create this buy-in by the process owners and implementers is usually sought through a back-end sales effort to convince them that the proposed changes are in their best interest. But often the sales effort comes off as saying to the process owners, if you were as smart as we are, you would adopt these changes. Needless to say, this is not well received. However, it became clear that the sense of ownership in both the as-is picture of the process and the changes which grew out of that model acted to remove the necessity for such a sales job. Many of the proposed changes were the result of process improvement ideas on the part of process owners along the way. Where other changes were necessary, they could often be elicited from the process owners through the use of strategic questions. When we saw opportunities to change the process for the better, we'd ask the process owners, what would happen if, and then we would lay out the potential alternative. The process owners would then generally adopt or refine the proposed change, and it would become a part of their model of the process to be. Problems with potential changes easily emerged and could be dealt with efficiently at this juncture. The end result was a model of the change process that had process owner buy-in when it was produced. Therefore, there was no back-end sales job necessary. Despite the value of the anticipated gains in clarity and accuracy that actually did come from our use of the iterative interviews, it was pretty clear to us that this avenue to smooth change management was probably the most helpful aspect of our approach. I hope this material has been useful and interesting to you and that you've enjoyed our time together this afternoon. The iterative interview approach turned out to be a fruitful endeavor for us. We were able to consistently obtain an accurate process model while involving the process owners in a way that built trust and commitment to the model and the proposed improvements. Please don't hesitate to contact me if you have questions or comments. Thank you. And now back to our studio crew.
Thank you, Zane. Now let's move on to your questions for our presenter. We've already received some great questions, and I thank you for submitting those. I encourage you to join the discussion and submit your questions at any time via the Q&A function in the GoToWebinar window. So let's get started. Our first question here is from David, and he asks, the methods you described today seem intended for situations where the output is a physical thing. Do you alter the methods at all when the output is a change in state?
Actually, David, we were not outputting something physical. We were actually outputting processes. I think it would have equal applicability in the physical realm, but that wasn't the way in which we developed it. We were actually looking at information analysis processes.
Okay, great. Thanks for that clarification, Zane. Our next question is from Billy, and he asks, will this work with information technology processes, such as customer relationship management or enterprise resource management processes, or will it only work to capture manufacturing steps?
No, and I see something that I've done right away. Because of the necessity of doing tangible representations, it looks like that I'm talking about manufacturing steps. But again, we were actually using a process that was done principally person to person and was driven on the steps taken by people in converting information for use by others. And so what you've outlined there as examples would be perfectly amenable to this, and actually would look more like the place where we originally developed it than a manufacturing or physical setting.
Okay, thank you. A question from Jim. He asks, won't asking the questions begin to change the process?
Actually, we didn't find that. Once you were clear with the process owners about what you were doing, the fact that you wanted to develop a model that reflected accurately what they were doing, and you wanted to understand their rationale for doing it, we found that we got a much more accurate picture than if we showed up and tried to observe it. We had some folks, frankly, in the very beginning of this development who were skeptical because they said just that. And as compared to, I call it time and motion because my first experience with it was in an industrial plant setting, but guy would show up with a stopwatch and a clipboard, and he would just stand off to the side and kind of watch you and make notes. You weren't sure what he was up to. You weren't sure what he was doing. Everybody had theories about who he was and why he was there. And so as opposed to that kind of a method, the straightforward questions, and we tried to build trust and build a relationship with the process owners. And we found that as long as we were genuine about that, that worked beautifully, and we didn't get the process distortions.
Great, thank you. And one last question before we wrap up, and this one is from Fred. And Fred asks, how do you capture the processes during the interviews? Whiteboard, sketch on a notepad, software product?
Technically the answer to that question is yes. What we did was we would sit down with the process owners, and typically we worked in groups of 3. One person would actually ask the questions and make notes on the answers. The second person actually drew the process. So we would draw the process for the process owner and get them to give us a nod of approval as we drew the process up. So we used newsprint in that situation. And then we had an engineer with us who was actually had a laptop and was using the Vitex Core tool to put the information into the model as fast as he could go. Now, we began the process back in the days of Core 5, and Core is now Core 8. And one of the most powerful things that has happened in that realm is that we now have drag and drop capability with Core 8 to actually do diagrams essentially working from scratch. So if I were doing this again, I could probably pull it off with two people and we could actually make the diagram representations right on the spot, which has the advantage of freshness that would allow the process owner to make corrections. So we were making written notes, we were making drawings, and we were entering information into the software tool, all three. And that approach would work even better today.
Thank you, Zane. Well, that wraps up our Q&A for today. If we weren't able to answer your question during the Q&A portion of our presentation, we'll contact you directly after the webinar to ensure that your question is answered. If you have any other questions or comments you didn't send in today, we invite you to post those on the forum of our community site. You'll find that at community.viteccorp.com. A recording of today's webinar will be posted to our website, viteccorp.com, by the close of business tomorrow. In closing, I'd like to thank our presenter today. I'd especially like to thank all of you for joining us as we kick off our fall webinar series. As we bring this webinar to a close, a survey will open on your screen, either in a new browser tab or in a new window. Please take a moment to provide us with feedback on today's presentation, as well as what topics you'd like to see covered in our future webinars. Thank you for joining us and have a great day.